Hello friends and welcome to Ace Education. In today's video, we are going to see a sectional orthographic problem where we can see a object being cut from the mid plane, how it can be viewed in the front view or side view or in the top view. In earlier video, we have seen simple orthographic projections where object is viewed from three different directions and then we draw these three different views with respect to xy line and x1 y1 line. So friends, let's start with this sectional orthographic problem and we'll see how it can be drawn and how it is different than the simple orthographic problem. So friends, we have this problem to draw its sectional view. But from which angle we are supposed to draw the sectional view? You can see here the arrow given for x. So this is what your front view. In the same way, when you will be looking from the top, that would be your top view. And when you are moving from the left, in the arrow of y, in the direction of y, that would be your left hand side view. But apart from that, you can see here the different arrows have been shown for direction A. Of course, the direction is same that of what x, but why it is shown on this axis line? Because we are going to cut this object along this axis line. So the whole object will be splitted into two equal parts. And then the remaining part or the part which is nearer to the observer will be removed. And then the retaining part we are going to view in the direction of A itself. So friends, this is the same object that we are going to draw. If we are supposed to draw normal front view, it would be like we will be rotating this object and we'll make it perpendicular to the plane. So this would be your normal front view. If you once you are going to view the same object from the top, that would become what? The top view. After getting its top view, we can rotate it further and we can see from the left hand side. So this way we get its left hand side view as well. But friends, we are going to see how the sectional front view can be drawn for this problem. So we'll be cutting this object from the mid plane so that this object can be cut along this plane itself. So you can see friends here how this after cutting the object from the mid plane, how it can be seen. Now wherever the surface is being cut, on that surface itself we are going to show the hatch lines. Hatch lines are supposed to be shown at an angle of 45 degree and it should be equispaced. You can see the white portion is what the surface where it is being cut, but you can observe inside this hole, this part is not a white part or this surface is not being cut, so it is not shown in white part itself. So we are going to leave this surface as it is only, and wherever surface got cut, we'll show that surface by hatching lines, except this rib, because rib is an extra plate that is being added for strength purpose. So once this object is being cut from the mid plane and we want to show all the hatching lines except the rib part, it can be seen like this way. So the whole surface where it is being cut, that surface has been shown by hatching lines. These lines are called hatching lines. We'll see how to draw this surface that is called sectional front view. This is like in the direction of X or in the direction of AA, we are going to draw the sectional front view. The rest of other two views, we are going to draw the normal view itself without being cut. So guys, let's start with the actual diagram. So friends, very first thing, we'll try to get the overall length, overall height and overall breadth of the object. If you see here in the direction of X, that is your front view, what would be the total length or overall length from extreme left hand side point to extreme right hand side point? That would become like, if you see distance from this point to the center point of the cylinder, that is given diameter is 60, so it is 30. So this distance you are getting 30. Apart from that, this surface is starting from the quadrant point itself. So we are measuring from this point itself. From this point onwards on right hand side, it is moving till center of this semicircular plate. So till that axis line, we are getting 38 distance, and then the radius of that semicircle would become what? Half of the diameter. Now this is what the diameter of the semicircle. So the radius would be half of that diameter, that is half of 60. So it is 30. So this distance would be 30, 38, and this is 30. So it is total 98. We are getting length 98. If you are calculating the total height, you can see the diameter of the cylinder is 60. So from bottom point to the top of the cylinder 60, then height of this block is 36, so it is 96, and then this height of this frustum of cone, it is given 40 mm. So 96 plus 40, it is 136. So very first one, with the help of this overall length and overall height, we'll draw the rectangle first. That would be indicating what? The frame for front view. After getting projection layer, we'll draw the XY line first. Make ortho mode on. Take a line command and draw a line around 300 scale. Take another line command and then draw approximate length from the midpoint itself. But we want to keep 20 mm gap here, so we'll between the two views. So we'll copy these both the lines on both sides by 10 mm each. Once it is done, now we'll start drawing the rectangle for the front view. In the length, we are getting length as 98. So I'm giving length as 98 and height it is 136. So tab key, give height 136 and then enter. So this is what the frame for front view has been made. Then go for rectangle and then you can calculate the size for the top view. In the top view, you can see the length is visible, and apart from length, the breadth would be visible. No height can be seen in the top view. Length we already have, that is 98, and the total or overall breadth in the side view, that is 80 mm, that is the size of what? Cylinder. So we'll draw another rectangle here from this corner point. Length would be the same, 98, tab. The breadth was 80, so tab 80 and then enter. Now we'll draw the side view. In the side view, we can see 80 mm as the breadth and the total height we have 136. So take a rectangle. From this point onwards, we'll draw the rectangle. The length would be 80, tab 136, enter. Once you draw all these three views, now it's time to draw the actual drawing. In the front view, direction of X, we must draw the two circles first, and to draw these two circles, we must have the center point. This center point can be drawn with the help of these two center lines, horizontal center line and vertical center line, that will be at a distance of radius of outer circle, that is 30 mm from this lower point and from left hand side point. So the center point is lying 30 mm distance from both the directions. We'll take layer as center and we'll draw the lines, and we'll draw the center line on left hand side plane as well as bottom line here itself. And then we can move these both the lines by 30 mm each on inward direction. 30, enter, move, 30, enter. Once it is drawn, now you can complete the circles by continuous layer. Take continuous layer, circle command, take intersection point as the center, drag the mouse outward, give radius 30, enter. Another circle having diameter as 30, so radius is 15. 15, enter. I can extend this line further beyond this circle. Once you draw these two circles, now we'll draw this plate. which is going 36 up from the quadrant point. So from this quadrant point, take a continuous line 36 up, and then from this corner point it is moving till end line itself, right? So we'll draw straight away till the end point. The length of this line would be totally 38 plus radius of this semicircle, that is 30. 38 plus 30, that would become 68. If you see the dimension of this line, it would be 68 itself. Now we'll come downward by distance 20 mm. So take a line command. From this point, come downward by 20, enter. Come towards the left by how much distance it will come here? That was 68 minus 20, so it would be 48, right? From this corner point, it went towards right by 68. It came downward and it will come 68 minus 20. We are getting 48. So give 48 and then enter. After that, after this corner point, it will reach to the circular profile. So I'll come downward. It would be very difficult to project that point, so I'll extend that line beyond circle. Then I'll trim that line. Now you have drawn this much profile. Now it's time to draw this rib part. You know that rib is starting from this point. When you are looking from the X direction, it can be seen from this corner point itself, and which will be tangent to this circular profile. So take a line command, and from this corner point, come downward on the circle and search the tangent point over the circular profile. You can see the tangent point is highlighting, where the tangent symbol also can be seen. Just click that point and escape to come out of that command. You can see this rib line has been made. Once this rib is made, now we will draw this frustum of cone. To draw this frustum of cone, we know that it is having base diameter as what? The 60 mm itself, as it is matching with exactly semicircular part, and the top diameter is having 40 mm. So to draw this 40 mm and 60 mm, we must have this axis line first. The axis line will be at a distance of again 30 mm from right hand side point. That is the radius of this semicircle. So we'll measure 30 mm and we'll draw the axis line over here. Change the layer to the center one. Take line command. I will draw the axis line on this right hand side plane. Then I will move this center line on left hand side by 30 mm and then enter. Once this axis is made, now we can draw the top line, which will be measuring 40 mm, because when you are looking from the X, the whole diameter line can be seen as a straight line which will be measuring 40 mm only. So take a line command with the continuous layer, and from this center point on the top plane, we are going to draw 20 mm on the right. Similarly, 20 mm would be towards the left would be there. So that total diameter would be 40 mm. We have radius of base circle as 30 mm and radius of top circle as 20 mm. So this is a 20 mm radius, this is 30 mm radius. Join these both the ends by straight line. Similarly, we can draw 20 mm on left hand side, but here also we must have 30 mm distance. So you can draw 30 mm line again and you can connect this one, or you can just mirror these lines. Go to the mirror command. This one is mirror command. Select the line which you want to mirror. I'm selecting both the lines. Then just right click and do left click on any 2 points on this vertical line, because this line we are considering as plane, mirror plane. Then press enter. You can see here the frustum of cone has been made. But this cone is hollow part, which is having whole diameter as 20 mm. So we want to draw the dotted lines which will be representing the hole present in that frustum of cone, for which I'm just extending this center line first, and then I'll copy this line both sides by 10 mm each, because the diameter of the hole is 20 mm. So I'll copy this axis line 10 mm each on right hand and left hand side. So go to the copy, select the center line, right click and give distance 10, enter. On left hand side, on right hand side 10, enter. But these two lines must be hidden one. Select these two lines and change the layer to the hidden. You can see this hole is starting from this plane, top plane, and ending on this plane, because the hole is always through hole. As you can see, the depth of the hole is not mentioned, so we are considering the hole as the through hole from starting from this top plane ending on this bottom plane. This way we have completed this normal front view, but we are supposed to draw the sectional front view. How it can be looked when it will be cut along this axis line. Obviously this surface is not being cut, but the edges would become dark. So I'll convert these hidden lines into what? The visible lines, that is continuous line. Apart from that, once it is continuous line, you can see the inside surface as the continuous from top to bottom, as it is single material, uniform material. So just trim these inside lines of circular hole. Now wherever surface is being cut, in that part you can show the hatch lines. Go to the hatch, select ANSI 31, that is already you can see the 45-degree lines which are equispaced. Select that pattern and click on the region where you want to see hatching lines. Here hatch will come, but inside the hole there will not be any hatchings. So click on this region as well. Inside the rib also there should not be any hatching lines inside the rib as per our rules. Now in the cylindrical wall there would be hatching lines. As you can see, the cylindrical wall also being cut, only inside surface is not being cut. All over the surface or all over the wall of this cylinder, hatching lines can be seen. Once it is done, you can directly close here. But in case if you see this hatching lines is too much dense or the scale between them is too much large, you can change the scale here either by below 1 or beyond 1. If I make it instead of 1 as 0.1, you can see how much dense it is. And if I give here like 5, that is above 1, you can see the distance between the hatching lines has been increased. So this is again trial and error method. You have to check it how much it will be suitable for your own diagram. Friends, as I told you before, that hatching lines must be a continuous one. No lines should come across any hatching region. So you have to trim all these lines which are coming within this hatching region. So this edge will not be there. Again, this edge also will be removed. Similarly, if you see, the part of this circle will not be visible because it is coming in between hatching lines. These are what center lines, which are imaginary lines. This is okay. So friends, this is what the front view we have just completed. Now we'll start the top view. If you see from the top view must be a normal view. So we are going to start with these two circles. Wherever circles are visible, these circles must be drawn first. So I'm going to start with these two circles, but before that, you know that whole top view is symmetrical about this axis of symmetry from which we have just cut this object, right? So we'll draw this axis of symmetry first from the midpoint of that plane or midpoint of that rectangle. So take center layer and we'll draw the horizontal line, because you can see when in the direction of X you'll be looking from the top, this axis line can be seen as horizontal line. So take a line command and search the midpoint of the line and join with the midpoint of the line on opposite side. Once this axis of symmetry is made, now you can go for vertical center line to draw the two circles of the cone. So we want to draw these two circles here. We'll take that center line from the front view also. So take projection layer, take a reference from this front view, and then by changing the layer again to the center layer, take line command. You can draw the center line along that projection layer itself. Once it is drawn, go to the continuous layer again, take a circle command and see the diameter of these both 20 and 40. So take intersection point. The first radius was 10, enter, and the second radius is 20, enter. So this way we have completed these two circles, but at the same time this cone is having its base diameter as 60 mm, right? So that circle would be visible totally. We'll take circle command again, and from the center point onwards we'll draw another circle of radius 30, enter. Once it is drawn, we know that this base of this cone, it is also matching with the semicircular profile of this plate also. So from this point, quadrant point, we'll draw straightaway two vertical lines, two horizontal lines of distance 30 mm each. Take a line command. From this quadrant point, we'll draw 30 mm towards the left. Similarly, from this point also 38 towards the left. And then join these 2 points. We have drawn the 60 mm line. Now we'll take projections of the cylinder, which can be seen as a rectangle from the top view. The cylinder can be seen as a rectangle from the top view. We'll take projections from the front view, take projection layer, line command. This projection we already have. We'll take projection from this point in downward direction, and then change the layer to the continuous one. Go to the rectangle command and draw exactly over this projection layer itself. Now this is what we have just drawn, the rectangle for the cylinder, but this line would not be visible because over which this block can be seen. So this line should be trimmed beyond this line itself. Once it is done, now you can see you already have created the line or rectangle on that projection layer itself, but it is not being visible because it is being hidden by projection layers. So click on that line, right click over there, go to the isolate and click on isolate objects. Now you can press Ctrl Z so that line can be seen over the projection layer now. We know that this cylinder is hollow one, so we can take projection of this circular hole also from the cylinder with the help of projection layer, where you can show the hidden lines for this circular hole. Take a hidden line again, line command. On this projection layer, draw this hidden line. You can change the scale. For that, I'm repeating command again, LTS, line type scale, enter. Now it is 0.3. If I give here 0.5, if I see the changes, you can see the dotted line can be seen properly. Anything else left in the top view? If you see from this corner point, one edge is going toward that point. So that edge should be shown over here as a hidden line on the surface itself. So this distance is 20 mm. So from this corner point towards the right, 20 mm, at a distance of 20 mm, we can draw the hidden line here for this edge. So we can take the reference from the front view as well. Take projection layer, line command. We want to draw the edge for these corner points. We'll move to this point itself, and then by hidden line itself, go to the line command. You can draw straightway hidden line for that edge itself, the edge which cannot be seen from the top. The edge which cannot be seen from the top, for that edge I have shown this dotted line. Similarly, the dotted line will come for these cylindrical outline as well, which line we have just trimmed before. On that line also the dotted line will come. So this is what the completed top view. Now we'll move to the side view. To draw the side view in the direction of Y, very first upon we must have this rectangle of our cylinder. We can take the reference from the front view. Take a projection layer, line command. You can take reference of this front view cylinder, and then by changing the layer to the continuous one, we can draw a rectangle for cylinder itself. We also know that the whole side view is symmetrical about this axis of symmetry the way it was for top view. So we'll change the layer again to the center layer, and from midpoint we'll draw the center line or axis line around which whole object is symmetrical. Once it is done, now we'll try to get the vertical plate here. We try to draw this plate which is having 36 mm height and 60 mm wide. So to draw this plate, vertical plate in the side view in the direction of Y, we must have the 60 mm height, 60 mm wide and 36 mm height, or we can take reference from front view as well. So we'll change the layer to the projection layer and we'll take the reference from the front view. We want to draw this plate over here. So we'll take reference of this plate. Right. So this height is maintained, that is 36. Only difference is that we want to draw 30 mm towards the right, 30 mm towards the left to have 60 mm wide here. Change the layer to the continuous line. Take line command. From this point onwards on the right hand side, we will draw 30 mm line. Similarly, from the center line towards the left, we will draw again another 30 mm line, and then it will come downward. Similarly, search another perpendicular point over that rectangle and click it. So we have drawn this plate now 60 by 36. Now we'll draw this rib which is 12 mm wide, and its projection can be taken from the front view. Change the layer to the projection layer, line command. One projection we already have because the rib is going to start from this top line itself, but it will be ending where it is tangent to the cylinder. So that tangent point can be projected from front view itself. We have this point, the end point of the rib. We'll project that point on right hand side in the side view. Now we can draw the rib here which is 12 mm wide. You can see here the rib is 12 mm wide, which can be seen in the direction of Y. To draw this rib which is 12 mm wide, you have to copy the center line on both sides by 6 mm each. So go and copy this center line on both sides by 6 mm each, and then select both the lines and change the layer to the continuous layer because this rib is continuously visible, and then trim unwanted lines, like rib must start from this line itself and it should end on this projection layer. So beyond that line you can trim both the lines. Similarly, this inside line also will not be visible. Trim that line as well. But you cannot open any single line. So you are supposed to draw a 3-point arc at the end points. So just make ortho off and draw the 3-point arc. First upon change the layer to the continuous one. Go to the 3-point arc. First, second, third. First, second, third. So this is like, it represents that this is tangent to the cylindrical surface. We are supposed to draw the similar kind of rib in top view also, because you can see here that in the top view this rib can be seen, that is again 12 mm wide, and we can take the projection from the front view also. So take projection layer. Obviously rib is going to start from this corner point, so that line we already have, but where it will end, so you have to project this point, make it ortho on, and just take it downwards. where you want to draw that rib. Change the layer again to the continuous one and just copy this center line on both sides by 6 mm each, as it is 12 mm wide. And then by selecting both the lines, change the layer to the continuous one and then trim unwanted lines. Go to the trim. You want this rib to be this projection layer itself. These are what unwanted lines, so just select these two lines and delete that. Here you have to draw the 3-point arc, make it ortho off, and then using this 3-point arc, first, second, third, again first, second, third. This way you can complete this rib in top view also. Now once it is done, now it's time to draw this part. Anything left here? Yes, the hidden line present for this corner point, this edge. So we are going to show this edge dotted line over this surface at a distance of 20 mm below this line. Or you can take a reference from front view also. Take projection layer, line command. For this edge, you will draw the projection line. Change the layer to the hidden one. Take line command again. And along this projection layer, you can draw the hidden line. We are going to turn off the projection layer so that only hidden line can be seen that time. Now we'll try to draw this frustum of cone. We already have axis line. Here also we have axis line. So we can just copy also the outline of that frustum of cone. So go to the copy command. Select the outlines of the frustum. And also select this whole part, circular hole. And copy all these line, right click it and do left click on this top plane at the center line. Second point, you have to click exactly center line on the top plane itself. So escape, come out of that command. You can see the whole part has been copied. But here these lines will be in hidden lines because it is a side view. In the side view you can see this hole is not directly visible from the y direction. So this hole must be shown in hidden lines. So that has been shown in hidden lines. Apart from that, hidden line will come for circular hole inside the cylinder also. Go to the projection layer, take line command and draw the projection for the circular hole. Make it ortho on. And then change the layer again to the hidden one. Line command, draw the hidden line and then second hidden line over here. So guys, once it is drawn, once all the three views are completed, you can directly turn off the projection layer. Just click on this bulb, turn off the projection layer, and you can see the projection layers are hidden now. Now you can give the dimensions the way it is given in the question, like the length of the cylinder, the diameters of the circles of the cylinder. So go to the dimension. Throughout the three views, you are supposed to give at least 8 to 10 dimensions. If I am giving this dimension in this way, it will become in hidden line. So select that and change the layer to the continuous one. Again change the layer to continuous one and now give the other dimensions in continuous layer itself. You want to give the dimension for circular hole, so just zoom it, click on the circle and drag it outward at approximately at an angle of 45 degree itself. Take dimension, zoom that circle, click on that circumference and drag it outward. So it will give you, this is diameter 30 is the diameter of inside circle and this is R30 is the radius of this outer circle. So the diameter would become 60. The other dimensions can also be shown, like these are the circles. So give dimension for the circle over here. Another dimension for the circle can be shown. I have taken this approximate angle as 30 degree so that at 60 degree angle, the diameter of this circle can be shown. So just zoom that, click over the circumference and drag it outward. Also 36 mm is the height of that vertical plate. Go and give dimension for this vertical plate as 36 mm. While giving dimension, make sure that your object line is not being mixed with the extension line. In the basics of AutoCAD, we have seen how to set the dimensions. Once it is done, like in the earlier video, we can create that rectangle and title block. So friends, this way the drawing can be made, the title block can be made here, where you can give your namings. Let's say I want to give the naming ABC, and then to make it visible, I'll select the text. I'll change the scale here 2.5 to 5, and then I'll press enter, and then I'll close this. If you want to increase the scale further, you can go to the same way, double click over there and change the scale by selecting the text only. So once the drawing is made, you can save your drawing and then go for converting this drawing to PDF one, for which you can use the printer command, for which you have to press Ctrl P. After doing Ctrl P, you can find printer name as AutoCAD to PDF. I choose an AutoCAD PDF high quality print. Then I'll go for paper size. Let's say I want to take a print on A3 size. So it is like A3 420 by 297. Then what to plot? You have to select here window and select the two opposite corner points of this rectangle where whole diagram will be fitted. Then click on this landscape, click on the center of the plot, and finally click on preview. Once everything is fine, then you can just right click there and you can plot. You can click on the plot and you can save your drawing wherever you want to save. So you can save your drawing in PDF. So friends, this way, after completing your drawing and giving the dimensions and naming your drawing itself, you can convert your drawing into the PDF. So friends, I hope you understood all the concepts that is related to sectional orthographic projections and how to draw it on AutoCAD. So thank you very much for watching and keep practicing.